Hello my dear students, today we will solve the numerical problems of chapter number 8 which are related to the combination of the resistances. So the practice problem 6, we will start from this. The problem is that the two cells each of EMF 1.5 volt and internal resistance 1 ohm are connected in parallel to form a battery, and then this battery is connected to the external resistance of 0.5 ohm and two resistances 3 ohm and 1.5 ohm in parallel. Okay, and then our first question is draw the circuit diagram. So the first line is two cells 1.5 volt are connected in parallel. So here are the two cells. Okay, this one is the positive terminal of a cell, this one is a negative terminal, positive and negative. These two cells 1.5 volt each connected in parallel. Okay, and this become the battery. Now this battery is connected to the external resistance of 0.5 ohm and the two resistance 3 and 1.5 ohm in parallel. So this one is the complete diagram, and current is from this to here. This current is called I. So this one is a circuit diagram. This is a A part. So the B part is, so the total EMF of the two cells is, now the EMF is of each cell is 1.5. Now the two cells are in parallel, so the total voltage remain 1.5 volt. Okay, no need to multiply by 2 because the cells are in parallel. So the internal resistance, now internal resistance of each cell is 1 ohm. So resistances are in parallel, so the internal resistance is 1 upon Rp. Rp is the internal resistance, that is 1 by 1 plus 1 by 1, because are in parallel it become 2 by 1, that is 1 by 2, it means 0.5 ohm is the internal resistance. Now you can see here 3 ohm and 1.5 ohm are in parallel, so the parallel combination of these two is 1 by 3 plus 1.5 is again become 1. So the total external resistance, now this is become 1 ohm and this is 0.5. So total, both these are in series, so the total resistance is 1 plus 0.5, it become 1.5. It means कि total internal resistance become 1.5 total. Okay, and this is again connected to the cells. So the total current I is equal to EMF upon R external resistance plus Rp is the internal, because both are in series. So put the values, 1.5 upon 1.5 plus 0.5 become this much. So you can calculate the value of I like this. 0.75 ampere is the total current, that is a main current in the circuit. So the C part is now, C part is the potential across 1.5 ohm resistance, that is in parallel this. So 1.5 ohm across this potential drop is V is equal to IR. R is parallel combination resistance is 1. So I is 0.75. So 0.75 volt is the potential across 1.5. So current across 1.5 is now I is equal to V upon R. Now V is 0.75 upon R is 1.5. So this become 0.5 ohm. So current in 1.5 ohm is 0.5 ampere. Okay, so the D part is a drop in potential across terminal of a battery. The total potential across the terminal of a battery, this much. This is E minus V. E minus V, now we know that is I into R. I current is 0.75 and R is 0.5. So multiply these two, then we get the answer 0.375 volt is the total potential drop in the terminals. So these are the 4 parts of practice problem 6. Thank you.